Hello, we're doing Chapter 1, Lesson 2 over Order of Operations. And obviously this is about order of operations, and we have the traditional PEMDAS, the parentheses, exponents, multiply, divide, add, and subtract. You notice that I've written it a little bit different here than it traditionally is. Usually it's written as this. However, there are a few examples that come up, like example B when we get to it, that when we look at it, this newer way of looking at it really lends itself to think about that. So in the first situation, situation A, we need to think about the order of operations as simply just steps. What do we look for first? Well, are there any parentheses? No. So we look for exponents. There's no exponents. Is there multiplication? Yes, there is. Between the 2 and the 3, there's multiplication. So we need to multiply that first. So 2 times 3 is 6. And then we drop down the addition of 5 and the addition of 3. Now, since it's both the same property, the same addition step, then we just simply add left to right. Obviously, we know it doesn't matter, but we do anyways. So we have 3 and 6 is 9, and 5 is 14. There's the answer for there. In situation B, now we look for it. We have no parentheses, so we're all set. We go to exponents. We have 4 squared, and that basically, well, sure, that means 16. The subtraction sign drops down. Now we have division and multiplication side by side. According to PEMDAS, we should multiply first. However, that's the error. A long time ago, people sat down and figured out, hey, in this situation, we need to go left to right. So we're going to divide first. So 15 divided by 3 is 5. Now we drop down the multiplication symbol, and we have 5 times 5 minus 16. Now obviously we multiply before we subtract, so 5 times 5 is 25. We subtract the 16, and we end up with the big 9 as our answer. Okay, on to the next board. Alright, we also have grouping symbols, and we know that parentheses can come in different directions. We have parentheses, open and close parentheses. We have brackets. And we also have these things called set notations. So, they are basically just used for the same way that parentheses are used. They could show multiplication, or they could show you that you need to look inside and do that operation first. In situation A, in the first part, we have 2 times 5. All right, so 2 multiplied by 5 is 10. In the next portion of that, we know that we should add 4 and 3 before we do anything else. So we have 4 and 3 is 7. We need to keep the parentheses. We bring the 3 down, the addition symbol down. All right, at this point, we know we need to multiply the 3 and the 7 first. We get 21. We drop the 10 down. And the last step to do is simply add. So we get 31. Okay, the problems can become much larger, obviously. And situation B lends itself to be more like more of your future formula work that you're going to see. So we have brackets, we have parentheses, we have exponents. So according to PEMDAS, we look for the parentheses first. Basically, you look for the innermost set of grouping symbols. So we have 30 divided by 6. Well, 30 divided by 6 gives you 5. So we want 5 squared. And you should rewrite it. Don't do too many steps at once. It's a bad habit to get into. All right, so now we have 5 squared. We add 5. Well, we know that exponents come before addition, so 5 squared is 25. Rewrite it. And now what's left inside the brackets? 5 plus 25 is 30. We have 2 outside. Now, obviously, you can't leave it like this, so you need to have the brackets there, which shows you that you need to multiply. 2 multiplied by 30 is 60. There's your answer. Now, going on to grouping symbols, we then move on to what appears to be a fraction bar. Now, obviously, a fraction bar really means that there's a problem on top as well as a problem on bottom. So, what you should do in this situation, since everything is being added on top and then there's multiplication on bottom, that you should simplify the problem on top, the numerator. We know that we need the square 4 first, so we get 16 plus 6. And what you can do is you can continue to simplify this, or you can go to the denominator and take each step one-on-one. It completely is your choice. 6 by 16 is 22. After doing many of these, sometimes it's better to go all the way across the numerator, and sometimes it's better to mix them a little bit, do the numerator, then do the denominator. On the bottom, the denominator, we have 3 squared. Well, 3 squared we know as 9. 9 times 4, well, that's 36. All right, at this point, we have 22 divided by 36. We know they're both even values, so we can divide at least a 2 out of them. So at this point, we get 11 over 18. Now 11's prime. It does not divide nicely into 18, so we know that that is our simplified answer. Now, here's the word evaluate. Remember, evaluate means solve for. Algebraic expression. Remember, algebraic expression is a mathematical expression that includes variables. So, we have an example here, a squared subtract the quantity of b cubed subtract 4c. Now, what you first need to do is substitute in your values. We know that a is to be 7. We know that b is to be 3, and c is to be 5. So, the first thing you should do is substitute in your values. Be careful not to lose what operation was intended. So a is 7 squared. Subtract, now we have b cubed, so that's 3 to the 3rd power. Subtract 4. Now what operation is holding 4 and c together? That's multiplication. So 4 times 5. And we close the parenthesis. All right, now we just revert back to PEMDAS. We know this parentheses, so we need to go inside first. What should we do? Well, we have exponents there. So 3 cubed, well, 3 times 3 times 3 is 27. Close the parenthesis there. And, well, do we subtract or do we multiply first? Well, we know we're going to multiply, so we simply can say 4 times 5 is 20. So yes, we did 2 steps there, but that's okay. On inside the parenthesis, we have 27 minus 20. That leaves us with 7. On the outside, we have 7 minus 7. Now, do I need the parentheses around that 7? No, not really. I just put it there to organize it. Basically, we're saying 7 minus 7, that's 0. That's your answer there, folks. If you have any questions, please make sure to see your teacher.